third session on sets. Up till now we have discussed the definition of sets, and then we also came to know of what the various elements of a set are. We also discussed the two different methods of representing the sets, the roster tabular form and the set builder form. Then we had a discussion on finite and infinite sets, and empty null void sets as well as equal sets. Now we have also discussed sets, subsets and supersets in our last session, and we had done a question on sets and subsets also. So it is time now to understand how to find subsets of a particular set. You would recall that a subset will contain all the elements which a subset has will also be present in set. This is the standard definition that we had seen in the last session. Now let us understand how to find subsets for a given set. So let us take an example. Suppose that Q is a set which has two elements A and B. Now if you want to find out the subsets of this particular set, then these are the subsets. And how do we find them? You will have to use a particular procedure. First, you take all the elements of a set one at a time. So this way we'll get the first two subsets. You can see here A and B. These are the first two subsets which we obtain when we take all the elements of the given set one at a time. Once we have done this, now we'll take the elements of the set two at a time. This way we will obtain A and B. Now we had also discussed in our last session that phi is a subset of any set. So in all, now we have got four different subsets: A, B, AB and phi. So this is the total number of subsets that a set having two elements can have. So we are getting here four subsets: A, B, AB and phi. There is a formula also to calculate the number of subsets that a set can have, and the formula is shown here: 2 raised to the power n, where n is equal to the number of elements in the set. Let us talk about this very example. Here we saw that Q, a set, had basically two elements, which means that in this case n is equal to 2. And now if we need to find out the number of subsets, we only have to do what? 2 raised to power n. Here n is equal to 2 because set Q has only two elements. So basically the total number of subsets would be 2 raised to the power n, or 2 raised to the power 2 is equal to 4. And this is what we have found out, that there are four subsets: A, B, AB and phi. So this is the formula that you can remember. So whenever you have to find out the subsets of a set, first of all find out how many subsets are possible, and then start writing down the subsets one by one. So let us discuss one more example. For a set A which has three elements A, B, C, you would recall from our last discussion that capital A, a capital alphabet denotes these sets, while the small alphabet denotes the elements of the set. So here the capital A is a set which has three elements, which are being shown here by small a, small b and small c. So these would be the subsets. We have used the same procedure. We have taken all the elements one at a time. Then moving forward, we took two elements at a time, and then three elements in one go. This way we were able to find out all the subsets of this set A. Now you can first of all also calculate the total number of subsets that can be there using the same formula you would remember we had discussed in the last slide, 2 raised to the power n, where n was the number of elements in a particular set. Here you see that set A has 3 elements, small a, small b and small c. So basically set A has got 3 elements. So 2 raised to power n will become 2 raised to the power 3, which is 2 into 2 into 2 is equal to 8. So we need to have 8 subsets. And here we can see that there are basically 8 subsets A, B, C. When we took one element at a time, taking 2 elements at a time, we have got 3 subsets A, B, B, C and C, A. And taking 3 elements at a time, we got A, B, C. And since phi is a subset of all these sets, so basically we have now got 8 different subsets. Now just a note of caution. When we started taking 2 elements at a time, A, B, there's no need to write BA, because AB, yesterday we had seen that the sequence in which the element appear, that has no bearing. It is immaterial, and that is why AB will be equivalent to BA, and that is why we have not mentioned it again. Likewise, BC would be equal to CB and CA will be equal to AC. So you don't need to mention them again because they are basically the same sets, basically the same subset. So instead of mentioning BA after AB, you should not be doing that. You just mention it. You don't worry about the sequence of the elements, because sequence of the element has no bearing on a particular set. So basically now we've got 8 subsets for A, which had 3 elements. Now let us discuss the power set. Now what is a power set? Power set is nothing but it is basically again a set of all the subsets of a set. Now it seems a little confusing, but we'll understand it using this example. Let's say there is a set Q which has got 2 elements. You can understand that the number of subsets would be 2 raised to the power n or 2 raised to the power 2, because n is equal to number of elements. Here number of elements is equal to 2, so 2 raised to the power n is equal to 2 raised to the power 2 is equal to 4. So basically we have got 4 subsets, and these are the 4 subsets A, B, AB and phi. Now if you create another set which includes all these subsets as its elements, then it will be called the power set. The power set will be A, this would be the first element, the second element is B, third element is AB and the fourth element is phi. Is this okay? So basically this is the power set of Q because it consists of all the possible subsets of Q. There were 4 possible subsets of Q, A, B, AB and phi. So we have created a larger set which includes all these 4 subsets, and that is why this is called the power set of Q. So this is how you find out the power set for a particular set. Now let us talk about the universal set. What do we mean by universal set? Well, universal set will contain all possible elements in a particular context. Now this is very important. You need to take care of this particular phrase while trying to find out universal set or while doing some calculation which includes universal set. It will contain all possible elements, but it has to be in a particular context. Now what do we mean by particular context? Please understand. If context is letters in English alphabet, the context here is all the letters in the English alphabet. So universal set would be all possible elements A, B, C, D till X, Y and Z. All 26 elements will be part of the universal set. And the context is we are talking of the English alphabet. Now let's say there is another set which is A and it has got 3 elements. You can understand that A will be a subset of U, and that has been shown here. A is an subset of U. Let us take one more example. if the context is all even numbers, you understand, all the numbers which are divisible by 2, 2, 4, 6, 8, 10, 12, so on and so forth, this will be the universal set. It will contain all the even numbers and it goes up to infinity, 2, 4, 6, so on up till infinity. So now if you have got A is equal to 100, 200, 300, 400, you can understand that all the elements in A, they are also divisible by 2. Basically they are also even numbers. So A would be again a subset of U, or the universal set. Now let us talk about the complement of a set. What do we mean by the complement of a particular set? Again, a little confusing definition, but we'll have a look at the example also. Now, complement of a set is a set which contains all the elements of the universal set which are not present in that set. So the complement is another set, or let us say like this: complement of A is another set A dash or AC. These are the notations which are used to denote the complement A dash or AC. So complement of a set A will be another set which we will denote by A dash or AC, which will contain all the elements of universal set which are not there in A. Let us take this example. If universal set is the set of all the English alphabets and A is equal to K, L, M, N, O, P, Q, R till V, X, Y, Z. So all the elements which are present in U but which are not present in A will give you the complement of A. So A dash or AC, or in other words the complement of A, is equal to all the elements which are present in U or the universal set but they are not present in A. So you can understand here, universal sets has all the elements from A to Z, while A starts from K and continues till Z, which means A, B, C, D up till J, these are the elements which are present in universal set but they are not part of the set A, and that is why A complement, which is shown here in the third line by A dash or AC, will be A, B, C, D, E till J. So this is how you find out the complement of a particular set. Let us take one more example. If the universal set, the context here is different, the universal set denotes all the BBA students, and if B is another set which denotes the BBA first year students, then what will be the complement of B, or what will be B dash, or what will be BC? B C or B dash, they are all symbols which denote the complement. So what would be the complement of B? So you can understand, in the universal set there are all the BBA students, which includes the first year, the second and the third year students, while B only has the first year students. So naturally the complement will be those elements which are there in universal set but they are not there in the set B. The elements which are not there in set B are BBA second year students and BBA third year students, and that is why B complement, shown here by B dash or BC, will be equal to BBA second year students and BBA third year students. Is this understood? Now let us attempt an example, attempt a question to understand this better. I have taken it up from the NCERT book. Let the universal set be equal to 1 to 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the roster or the tabular form. Again, a set A has been given which has 5 elements. All of them are odd digits 1, 3, 5, 7 and 9. What will be A dash? So A dash, again A dash means the A complement. The complement of A will be all those elements which are there in U but they are not part of A, which means 2, 4, 6, 8 and 10. So the answer to this question will be that A complement is 2, 4, 6, 8 and 10. Let us discuss a few more examples. Here U is a universal set which has 6 elements 1, 2, 3, 4, 5, 6. A is equal to 2, 3 and B is equal to 3, 4, 5. So can you find out the complement of A? Find A dash, find B dash. So can you find out the complement of A and complement of B? So let us first try and find out the complement of A and B. So what will be the complements of A? A has got 2 elements 2 and 3, and the remaining elements which are part of U but they are not part of A are 1, 4, 5 and 6, and that is why A dash has been shown as 1, 4, 5, 6. An element which has 4, a set which has 4 elements 1, 4, 5 and 6. Again B has got 3 elements 3, 4, 5. The remaining elements which are not there in B but they are part of U are 1, 2 and 6, and that is why B complement here has been shown as 1, 2 and 6. As for the remaining parts of these questions they are concerned, A dash intersection B dash, we are yet to go through these concepts. So once you go through those concepts, you would be able to solve these questions also. As of now, you restrict yourself to calculating A dash and B dash, and we have understood how to calculate A dash and B dash, or A complement and B complement. Now we are going to use a diagram to represent the sets. So we are now going to discuss the pictorial representation of a universal set and its complement. The diagram that we will be using is called the Venn diagram. Why is it called the Venn diagram? Because Venn was a mathematician who actually for the first time came up with these diagrams, which gave us a more convenient manner to depict the sets, and that is why these diagrams are named after him, and they are called the Venn diagrams, V-E-N. So now let us see how you represent universal set and the complement of a particular set using the Venn diagram. So suppose A is equal to vowels in the English alphabet. So A is a set which contains only vowels in the English alphabet. You can understand that it will have 5 elements: A, small a, E, I, O and U. While U is the universal set which contains all the letters in the English alphabet. Now what will be A complement? Here I have used the symbol AC. You can also use A dash. So what would be the complement of A? The complement of A will contain all the elements which are part of the universal set but they are not part of the set A. Set A only has vowels, while universal set has all the elements, all the alphabets in English, all the letters in the English alphabet, which means vowels as well as consonants, and that is why A complement will be a set which will have only consonants. Is this understood? Now, I hope you know what consonants are. So all other letters except the vowels are the consonants. For example, B, C, D, F, G, H, J, K, L, so on and so forth. Since there are 5 vowels in the English alphabet, naturally the remaining ones are the consonants. They are basically 21 in number. So A complement, that is why A complement will be a set of only the consonants, because consonants are those elements which are part of the universal set but they are not part of the set A, because set A only contains vowels. Is this understood? Now let us try and depict it using the Venn diagrams. So let us first depict the set A. We generally make use of these kind of rounded shapes or oval shapes to denote a set. So this set A will contain 5 elements, all the vowels in the English alphabet, A, E, I, O, and U. The sequence is not important, we have seen earlier also. The sequence is not at all important. That is why you see that we start here with A, I, and then we move a little towards the north, and then we are mentioning O here. The sequence is not at all important. So here we have shown the sequence as I, O, U, E, and A, and it is equivalent to A, E, I, O, U. So this is how we are depicting the set A. Now what will be the universal set? Universal set will be the set which contains all the elements. It should also include A, and that is why we are using this box to represent, to show the universal set, because the universal set will also contain the set A, because universal set is a set which contains all the elements which are possible in a particular context. Here we are talking about the English alphabet, so all the elements which are there in the English alphabet, including the vowels which are the elements in set A, all these elements would be part of the universal set, and that is why the box that shows the universal set U is encircling the circle which is denoting the set A. Now, which space denotes the complement of A? Again, we can go back to our definition. All the elements which are there in U, but they are not part of the set A. Basically, all the space which is there in the box, but which is not a part of this rounded shape, all that space is complement of A, and this is what we have shown here. This is basically the complement of A, and we are denoting it using the notation AC. And I have just shown a few elements here, B, Q, Z, J, T, G, P. Though this empty space, though this is space which is outside the circle and inside the box, will have basically 21 elements, 21 consonants, starting with B, C, D, F, G, H, J, K, L, M, N, P, Q, and so on and so forth. So this is how you have to depict the universal set and its complement. Now you can also understand that the circle which denotes the set A and the outside space which denotes the complement of A, they actually add up to form the universal set. So in a way we can also say that A plus the complement of A is equal to the universal set U. So A plus AC is equal to U. So that's all in this particular video session. I would like you to go through this video lecture in a thorough fashion, so that when we start discussing some more representations, diagrammatic representations or use of Venn diagrams, and we start discussing the operations of sets. By operations I mean how do we add up two sets, how do we multiply two sets. So when we'll be discussing these things in the next video session, I would want you to be prepared with whatever we have discussed till date, so that you can better grasp the contents that we'll be discussing in the next session. So kindly go through this in a thorough fashion and please prepare for the next session. We'll also very soon have a test. Thank you very much.